checks if the server process was interrupted somehow. It has to terminate, so type out u property parentheses f timer handle, and then we'll call this variable handle process termination handle. And lastly, we need a timer handle for a delegate function that will constantly do one of two things. It will either be checking for when a game session activates, or when the onUpdate game session handler function gets called. A game session activates once in the lifetime of a server process, in our case, just to make things easier since we will be ending the server process after the end of every game. After that, the function tied to this timer handle will only check for updates to backfill requests, and normally I would separate the two checks into two separate functions, but I'm going to combine them into one function just to make this tutorial a little faster by typing u property and then parentheses f timer handle, and then we'll call this variable handle game session update handle. Moving on, we need a member variable of type fHTTP module pointer since we will be making an HTTP request at the end of the game to the record match result API endpoint. So type out fHTTP module star HTTP module. And of course, we have to get the API URL from the text file in the URLs folder and store it somewhere. So type down here u property parentheses f string API URL. Also, since we added a Lambda authorizer to the record match result API method, let's keep track of the value that the Lambda authorizer will be expecting. Although we will get this value from the command line arguments, we should store it somewhere as well. So type u property parentheses f string server password. Now let's make a property for the amount of time remaining in the game. Although it will start at 240 because that's 4 minutes and seconds, this number will go down every second. So let's type u property parentheses and then int remaining game time. And also let's have a Boolean member variable to keep track of when the game session gets activated on the server process. So type u property parentheses bool game session activated. Now let's define all the delegate functions for those timer handle properties that we made earlier. So type u function parentheses void count down until game over parentheses, and then u function parentheses void end game parentheses, and then u function parentheses void pick a winning team parentheses, then u function parentheses void handle process termination parentheses, and lastly u function parentheses void handle game session update parentheses. And let's define one more function, which will be the response handler function for the HTTP request to the record match result API endpoint at the end of the game. So type out void on record match result response received. And then this function will take in 3 parameters. First one will be of type fHTTP request PTR, and it will be called request. Second one will be of type fHTTP response PTR called response, and the last one will be of type bool called b was successful. Now let's go to the GameLift tutorial game mode C++ class so that we can actually initialize some of those properties we just defined as well as implement the functions we just defined. Before we do that, let's add some include statements here at the top of the file. So just type hashtag include in quotes text reader component.h, and then hashtag include in quotes kismet/gameplay static.h, and then type out hashtag include in quotes json.h, and lastly hashtag include in quotes json utilities.h. Now let's move on to the constructor method and initialize some default values, starting with the API URL string. So first we need the custom text reader component that we wrote. So type out u text reader component. Sorry about that, missed the first letter. U text reader component star text reader equal create default sub object, and then in carets, u text reader, sorry about that guys, u text reader component, and then in parentheses pass in text, and then in parentheses and in quotes, text reader com. And then just read the value from the text file and store it in the API URL variable by typing API URL equal text reader arrow read file, and then in parentheses and in quotes the path of the text file relative to the content folder. So the file was in the URLs directory and it was called API url.txt. And then let's instantiate an object of type fHTTP module and set our HTTP module variable to the address of that object by typing HTTP module equal and then ampersand fHTTP module double colon get parentheses. And let's also give some default values to some of the game mode's member variables. So for example, remaining game time. Like I said earlier, we want a game to last approximately 4 minutes. So in seconds, that's 240. And as for the game session activated property, by default, that will be equal to false. Moving on to the begin play function, we are going to start by modifying the onStartGameSessionHandler function to parse that matchmaker data that we were talking about earlier so that we can populate the player ID to player team app variable in the game mode start game session state struct. So inside this onStartGameSessionHandler function, let's get the matchmaker data from the game session object by typing fstring matchmaker data equal game session obj dot get matchmaker data parentheses. Then let's deserialize this JSON formatted matchmaker data string, which will require a JSON object and a JSON reader. So type t shared ptr and then in carets f JSON object. We'll call this variable JSON object, and also type out on the next line t shared ref carets t JSON reader and then carets, and we'll call this variable reader, and we'll set it equal to t JSON reader factory and then carets double colon create, and then in parentheses pass in the matchmaker data variable. Now let's actually perform the deserialization, converting the JSON string to a JSON object, and check if it's successful by typing if in parentheses f JSON serializer double colon deserialize, and then in parentheses pass in the reader object and as well as the JSON object, and then squiggly brackets. And if the deserialization was successful, let's start extracting fields from this JSON object. Now remember that we looked at this example matchmaker data string earlier in the tutorial, but I just want to pull it back up here to remind you guys to check the link out in the description to see this example, because it can help give a better idea of what fields we are getting from the matchmaker data. But back to the code, let's first get the matchmaking configuration ARN and store it in our game session state by typing state arrow matchmaking configuration ARN equals JSON object arrow get string field, and then in parentheses and in quotes the name of the field, which in this case is matchmaking configuration ARN. Now let's get the teams array, so type out t array caret t shared ptr carets of JSON value, and call this variable teams, and we'll set it equal to JSON object arrow get array field, and then in parentheses and in quotes the name of the field, which in this case is teams. And then let's iterate through this teams array by typing for in parentheses t shared ptr and then carets f JSON value team colon teams and then squiggly brackets. Then let's convert the pointer to an FJSON value to a pointer to an FJSON object so that we can further extract fields by typing t shared ptr and carrots FJSON object. And then we'll call this variable team obj, and we'll set it equal to team arrow as object parentheses. Now we can get fields from this team object, for example, the name of the team. So type out fstring team name equal team obj arrow get string field, and then in parentheses and in quotes the name of the field, which in this case is just name. And let's also get the players array in this team object by typing t array and carrots t shared ptr and carrots FJSON value. And then we'll call this variable players and set it equal to team obj arrow get array field, and then in parentheses and in quotes the name of the field, which is in this case players. Now let's iterate through this players array by typing for in parentheses t shared ptr and then in carrots FJSON value player colon players square the brackets. And just like with the team, let's convert this pointer into a pointer that points to an FJSON object. So type out t shared ptr and carrots FJSON object. Call this variable player obj, and we'll set it equal to player arrow as object parentheses. Now we can extract fields from this player object. So for example, with the player ID, type out fstring player ID equal player obj arrow get string field, and then in parentheses and in quotes the name of the field, which in this case is player ID. Now let's extract the attributes field and get the actual skill value. So type t shared ptr and carrots FJSON object attributes equal player obj arrow get object field, and then in parentheses and in quotes name of the field, which in this case is attributes, and then t shared ptr and carrots FJSON object skill, and set this equal to attributes arrow get object field, and then in parentheses and in quotes the name of the attribute field, which in this case is skill. And then let's get the actual value of the skill by typing fstring skill value equal skill arrow get string field, and then in parentheses and in quotes the name of the field, which is value attribute. And I've said this before, but I'll say it again because it's kind of strange to look at, but attributes in the attributes array come in objects that contain not only the type of the value of the the type of the attribute, but also the actual value of the attribute. So even though the skill value is a string, it's apparent in the type field of the attribute that it is of type double. Now let's create an object of type AWS GameLift Server Model Attribute Value, because we will eventually instantiate an object of type AWS GameLift Server Model Player for our start game session states player ID to player map. Again, this is for helping us determine the team of incoming players as well as handle backfill for later. So type auto. Remember, the auto keyword is used for avoiding typing out really long variable types. So we'll call this variable skill attribute value, and we'll set it equal to new AWS :GameLift :server :model attribute value, and then in parentheses let's pass in the skill value but converted to a variable of type double. So to do that, type out fc string ATOD, and then in parentheses pass in star skill value, and then add a semicolon at the end. Now let's actually instantiate the AWS GameLift Server Model Player object by typing AWS :GameLift :server :model : player AWS player obj. And let's set the player ID of this object by typing AWS player obj dot set player ID, and then in parentheses pass in tchar underscore 2 underscore ANSI in all caps, and then in parentheses pass in star player ID. Then let's set the team by typing AWS player obj dot set team, and then in parentheses tchar underscore 2 underscore ANSI in all caps, and then in parentheses star team name. After that, let's set the skill attribute by typing AWS player obj dot add player attribute, and then in parentheses this function will take in two parameters. The first one will be the name of the attribute in quotes, so that will be skill, and then the second parameter will be the actual attribute value object. So type in star skill attribute value. And finally, let's add this player object to our map by typing state arrow player ID to player dot add, and then in parentheses pass in player ID as the key, and then AWS player object for the value. And that is it for the onStart game session handler function. Let's move on to the onProcess terminate handler function, because I do want to make a very small change. Since we are going to handle process termination now in a separate function, remove all the code in this handler function after this if get termination time outcome that is success statement, but keep the line of code that sets state arrow status equal to true. So copy that line of code, then get rid of this snippet of code, and then paste that line of code back in, because we still need a way for that new handle process termination function to be able to know when a server process has been interrupted for whatever reason. Then moving on to where we parse the command line arguments, since we will now be expecting a password command line switch in addition to the port, let's make sure that we get the value for that password command line argument and store it in the game mode server password variable. So type inside this for loop that iterates through all the command line switches inside the if statement that splits the switch into the name and value of the argument. Right after the if statement, check to see if the switch being iterated on is the port switch. Type out else if in parentheses key dot equals, and then in parentheses and in quotes password, and then in squiggly brackets set server password equal to value. And I seem to have missed a closing squiggly bracket. Note that when you're writing code inside the compiler derivative, so the hashtag if, hashtag end if block, sometimes the autocomplete can be a little funky. As I keep writing code inside this class throughout this tutorial, I'm going to remember to write the hashtag if with game lift, hashtag end if compiler derivative after writing all the code. So just keep that in mind. So as you're writing code, make sure that you are including all of those closing including all those closing parentheses and squiggly brackets. The last thing we're going to write in the begin play function is going to be at the very end of this function. So after the end if compiler derivative, we're going to call set timer specifically on the handle game session update and handle process termination functions, because a game session can be activated and a server process can be interrupted as soon as the server process starts up. So we have to start calling these functions on loop immediately. So type out get world timer manager parentheses dot set timer, and then in parentheses this function takes in 6 parameters. The first one will be the timer handle object, so type out handle game session update handle. Next parameter will be this. Third parameter will be the address of the function to be called, so ampersand a game lift tutorial game mode handle game session update. Next parameter will be the rate at which the function will be called on loop, if at all. So we're gonna have this function get called every second, so type in 1.0f. Next parameter is a boolean denoting whether or not this function will get called on a loop, so type in true because yes, we do want this function to keep getting called over and over again. And then the last parameter is the initial delay before the very first time that this function gets called. So we're going to set that equal to 5.0f. So this function will get called the very first time after 5 seconds from calling set timer. And then we're going to do the exact same thing for the handle process termination method. So type out get world timer manager parentheses dot set timer, and then in parentheses pass in handle process termination handle process termination handle, comma this, comma ampersand a game lift tutorial game mode double colon handle process termination, comma 1.0f because we want the function to be called once a second, comma true because we do want the function to get called on a loop, and then comma 5.0f to make this function get called for the very first time after 5 seconds of calling set timer. Now let's override the pre-login function, so go down and type here void a game lift tutorial game mode double colon pre-login, then in parentheses const f string ampersand options, comma const f string ampersand address, comma const f unique net id repl ampersand unique id, comma f string ampersand error message, and then a pair of squiggly brackets. And the first thing that we are going to do is call the game mode based parent classes version of the method. So type super double colon pre-login, and then in parentheses pass in these same 4 parameters that the pre-login function is taking. So type in options, comma address, comma unique ID, comma error message. And before I move on, I just want to mention what we will be doing in this method. So the pre-login function, like I mentioned before, is for authenticating incoming player connections. And if you believe that an incoming connection should be rejected, then all you have to do is set the error message parameter passed into the pre-login function to any non-empty string value. So that once the pre-login function is finished getting called when a client tries to connect, the game mode class's inherited login function will get called, and that method will just simply check the value of the error message parameter, and if it is not empty, then the login method will return null pointer for the player connection or for the player controller, and as a result, the player will get kicked out of the game. So how are we going to decide whether or not a client should be able to connect to the game? Well, first we have to make sure that the client pass some options when calling open level. Otherwise, we can't get the player session we can't get the player session ID and player ID values. So type out if in parentheses options.len parentheses greater than 0 squiggly brackets, and like I just mentioned, if the client doesn't pass in options, then we should consider rejecting this incoming player connection. So type out else squiggly brackets, and then error message equal in quotes. This can be anything, but I'm just going to make it unauthorized. But if the client did pass options when calling open level, then let's extract the player session ID and player ID values from those options by writing const f string ampersand player session ID equal u gameplay statics double colon parse option, and then in parentheses this method will take in 2 parameters. The first one will be the options, and the second one will be the name of the specific option that you want to parse out. So in quotes, this one will be player session ID. And next up, type out const f string ampersand player ID and set that equal to u gameplay statics double colon parse option, and then pass in parentheses options, and in quotes this time it will be a player ID since we want to parse out the player ID option. Now another reason that we would reject an incoming player connection is if the client didn't pass in either a player session ID nor a player ID value. So let's check for either of those possibilities by typing if in parentheses player session ID dot len parentheses greater than 0 double ampersand player ID dot len parentheses greater than 0, and then squiggly brackets. And like I just mentioned, we want to reject an incoming player connection if either one of these options that we're looking for are not valid string values. So type out else, squiggly brackets, and let's copy this line where we set error message equal to unauthorized in quotes and just paste it in this else block here. But going back up, if the client did pass in both a player session ID and player ID through the option, then let's make sure that these two values line up with each other, meaning that the player ID is associated with the player session ID, because when a matchmaking request gets fulfilled, each player in the request who is uniquely identified by a player ID will be assigned a unique player session ID. So what we can do to check this is by calling the GameLift server describe player sessions method in the AWS namespace. So to do that, we need to first create a describe player sessions request object by typing AWS :GameLift :server :model :describe player sessions request, and we'll call this variable describe player sessions request. And let's set the player session ID in this request by typing describe player sessions request, and we'll do .set player session ID, and then in parentheses type out tchar _2_ ANSI in all caps, and then in parentheses pass in star player session ID. And then let's actually call describe player sessions by typing auto describe player sessions outcome equal AWS :GameLift :server describe player sessions, and then in parentheses passing the describe player sessions request object. Now let's check if the call to describe player sessions was successful by typing if, and then in parentheses describe player sessions outcome, that is success, parentheses, and then squiggly brackets. Because if it wasn't usually due to an invalid player session ID, let's reject the player connection by typing underneath this else squiggly brackets, and then copy the line where we set error message equal to unauthorized in quotes and just paste it in this else block. But if the call to describe player sessions was successful, then let's look at the player session object return by typing auto describe player sessions result equal describe player sessions outcome dot get result parentheses. And note that the player session object will be in an array, because when calling describe player sessions, you can pass in one of three parameters, either a player session ID like we just did and get an array with one player session object back, a game session ID and get an array with all the player session objects currently in that game session, or a player ID and get an array with all the player session objects associated with that player ID in its lifetime. Since we passed in a player session ID, we are only expecting one player session object in the player sessions array return, so type out int count equal 1, and then auto player sessions equal describe player sessions result dot get player sessions, and then in parentheses passing the count. And just to be safe, let's just do a null pointer check on the player sessions array by typing if in parentheses player sessions not equal null pointer, and then squiggly brackets. And if for whatever rare reason that it is null pointer, then let's reject the incoming player connection by writing else, and then squiggly brackets, just copy the line where we set error message equal to unauthorized in quotes and just paste it in there. But going back up, in the case where we do have a player sessions array, let's get the first entry in this array by typing auto player session equal player sessions square brackets 0. And of course, let's get the player ID that we expected to be associated with this player session by writing f string expected player ID equal player session dot get player ID parentheses. And then let's get the status of that player session by typing auto player status equal player session dot get status parentheses. We need this because in GameLift, when matchmaking requests get fulfilled and lead to an event of type matchmaking succeeded, meaning that an available server process was found in the fleet in the queue associated with the matchmaker for hosting a game session for this new match. When that happens, player session objects are made for each player in the match, and they stay in the reserve state for 60 seconds until they transition into the timed out state. Now in this tutorial, we are only going to let players join within that 60-second time frame when the player session is in the reserve state. Because if the player session is timed out, then we're going to assume that the player took too long to join. If the player session is in active state, then that means the player is currently in the game, because as you will see shortly, in the case where we don't reject incoming player connection, we call a GameLift function to accept the player session and mark it as active. And of course, if the player session is in the completed state, then that means that the player was in the game at one point and then left, as we will see when we implement the logout method. And in that case, for this tutorial, we won't let players leave and join back unless they make a backfill request and get back into, unless they make another matchmaking request and that gets paired with an existing backfill request for the same game that they were originally in, and that player ends up getting back into the same game through flex match, and they get a new player session ID as a result. So let's check two things. One, whether or not the expected player ID is the same as the one passing through the options, and two, whether or not the player session is in reserve status. So let's type if in parentheses expected player ID dot equals in parentheses player ID double ampersand player status double equals AWS double colon GameLift double colon server double colon model double colon player session status double colon reserve, and then squiggly brackets. And of course, if either one of these two conditions evaluates to false, then we should reject the incoming connection. So type underneath this if statement else squiggly brackets, copy the line where we set error message equal to unauthorized in quotes, and paste it in this else block. And like I mentioned earlier, if the player ID passed in is what we expected and the player session is in reserve status, then let's mark the player session as active by calling the GameLift server accept player session method, because we are not going to reject the player connection in that case. So type out auto accept player session outcome equal AWS double colon GameLift double colon server double colon accept player session, and then in parentheses this method will take in one parameter, so pass in tchar underscore to underscore ANSI in all caps, and then in parentheses pass in star player session ID. But in rare occurrences, the call to accept player session can fail. So in this final case, let's reject an incoming player connection by typing if in parentheses accept player session outcome dot is success parentheses, and don't forget, sorry, I meant to say if not accept player session outcome dot is success, so make sure you have an exclamation point, or sorry, an exclamation mark before accept player session outcome dot is success, and then squiggly brackets, just copy the line that where we set error message equal to unauthorized in quotes, and just paste it in this if statement. And lastly, just to finish this method, since we wrote a lot of GameLift related code, let's wrap everything after the first line of this function. So scroll up inside the hashtag if with GameLift hashtag end if compiler directive. So let's type up here hashtag if and then with underscore GameLift in all caps, and then scroll down to the end of the function and type out hashtag end if. Now let's move on and implement the logout function by typing void a GameLift tutorial game mode double colon logout, and then in parentheses a controller star exiting, and then squiggly brackets. And before we call the parent class's logout method, let's do our own custom logic first, because it does involve the exiting controller parameter passed in. So let's first be extra cautious and do a null pointer check on it by typing if in parentheses exiting not equal null pointer and squiggly brackets. And if the exiting parameter is not equal to null pointer, then let's get the player state from that controller object, because that player state object contains properties such as the player session ID. And like I mentioned earlier when we were coding the pre-login function, when a player leaves, we want to set that player session associated with that player session ID as completed. So let's type a player state star player state, and we'll set equal to exiting arrow player state. And then let's do a null pointer check on that as well by typing if player state not equal null pointer, and then squiggly brackets. Let's cast the player state to a pointer of type GameLift tutorial player state by typing a GameLift tutorial player state pointer GameLift tutorial player state, and set that equal to cast in caret a GameLift tutorial player state, and then in parentheses pass in player state. And before we keep writing code, I forgot to explain when this logout method that we overwrote gets called. So whenever a player with a controller with the player state leaves the game, or the controller is destroyed, this method gets called. That's why here it's actually good to do the null pointer checks, because very rarely this method will be called when the player controller gets destroyed. Although in this tutorial that should not happen, so normally this method only gets called when a player leaves the game, and in that case we will call the GameLift server remove player session method to mark the player session as completed for GameLift and backfill purposes. So let's get the player session ID by typing const f string ampersand player session ID, and set that equal to GameLift tutorial player state arrow player session ID. And let's check if the player session ID contains a valid string value by typing if in parentheses player session ID dot len parentheses greater than 0 squiggly brackets, and if it does, then let's call remove player session by typing aws GameLift server remove player session, and then in parentheses pass in tchar _2 _ANSI, and then in parentheses type in star player session ID. And that's pretty much it for our custom logic. So let's wrap this snippet of code in the hashtag if with GameLift hashtag and if compiler directive. So type up here hashtag if with _ GameLift, and down here hashtag and if. After our version of the logout method is done, let's now call the parent class's version of the logout method by writing down here super logout, and then in parentheses exiting. Now let's go back to the initNewPlayer method that we defined earlier and wrote some testing logic for, but now let's actually write this function the way it is meant to be written. So initNewPlayer is supposed to be used to customize players based on incoming options passed into a call to open level. Therefore, we should be extracting those player session and player ID values from the options like we did in the pre-login method, and actually set the properties in the player state to those values so that we can access them in other methods like the logout method, for example. Now, before we extract the player session ID and player ID values from the options, just like how we did it in the pre-login method, I just want to note that this initNewPlayer method gets called after the pre-login method. So we don't have to do the same validation checks on the lengths of the option string as well as the result of the parsing of the option string, because the pre-login function took care of that for us, and the only way for an incoming connection to pass the pre-login check is if that player passes in a valid player session ID and player ID through the options. So let's get those values by typing const f string ampersand player session ID equal u gameplay statics parse option, and then in parentheses options comma in quotes player session ID, and then const f string ampersand player ID equal u gameplay statics parse option, and then in parentheses options comma in quotes player ID. And now let's do a quick null pointer check on the new player controller parameter by typing if in parentheses new player controller not equal null pointer, squiggly brackets. Now let's get the player state from the player controller, pass into this method by typing a player state star player state equal new player controller arrow player state. And then let's do a null pointer check on that as well by typing if in parentheses player state not equal null pointer, squiggly brackets, and then let's cast the player state pointer to a GameLift tutorial player state pointer by typing a GameLift tutorial player state star GameLift tutorial player state equal cast, and then in carrots a GameLift tutorial player state, and then in parentheses passing the player state. And of course, let's do a null pointer check on that as well by typing if in parentheses GameLift tutorial player state not equal null pointer, squiggly brackets, and after all those null pointer checks, let's set the player session ID and matchmaking player ID properties by typing GameLift tutorial player state arrow player session ID equals star player session ID, and GameLift tutorial player state arrow player, sorry, not player ID, matchmaking player ID, because remember the player state class has a built-in player ID variable, so we don't want to mess with that at all. So that's why we define our custom property with a different name. So matchmaking player ID equals star player ID. Keep in mind, don't get the matchmaking player, or don't get the player ID used in matchmaking requests to GameLift Flex Match confused with the built-in player ID in Unreal Engine's player state class. Now the server from this point on will be able to access the player's player session ID and matchmaking player ID through their player state instance. But we also have to set the team property. Luckily, we have an easy way to get a player's team from the matchmaker data retrieved in the onStart game session handler function. So let's look inside the player ID to player map in the start game session state object by first checking if the map is even populated by typing if in parentheses start game session state dot player ID to player dot num parentheses greater than 0 squiggly brackets, and if it is, let's see if the player ID is in the map by typing if in parentheses start game session state dot player ID to player dot contains in parentheses player ID squiggly bracket. And if it does, let's get the player object associated with that player ID from the map by typing auto player obj equals start game session state dot player ID to player, and then dot find in parentheses player ID. And then let's set the team property of that player object by typing fstring team equal player obj arrow get team parentheses. And finally, let's set the team property in the player state to that team value by writing GameLift tutorial player state arrow team equals star team. And then to finish this method for now, let's wrap the code that we just wrote with the hashtag if with GameLift hashtag and if compiler directive. So up here, let's type hashtag if with underscore GameLift, and then down here, let's type hashtag and if. And that should be it for now for the overridden methods. Now we can move on to implementing our timer delegate functions that make up most of our quote-unquote simple game logic. So starting with the countdown until game over method, let's write void a GameLift tutorial game mode double colon count down until game over parentheses squiggly bracket. And this method will be responsible for updating the latest event property in the game state to denote how much time is left in the game. So let's check if the game state is null pointer by typing if in parentheses game state not equal null pointer, and then squiggly brackets. If it's not, then let's cast the game state pointer to a GameLift tutorial game state pointer by typing a GameLift tutorial game state star GameLift tutorial game state equals cast, and then in carrots a GameLift tutorial game state, and then in parentheses passing the game state. And of course, let's do a null pointer check on that as well by typing if in parentheses game left tutorial game state not equal null pointer, squiggly brackets. If it's not null pointer, then let's set the latest event property. So type game left tutorial game state arrow latest event equals f string double colon from int in parentheses remaining game time plus in quotes space seconds until the game is over. Now, when this function eventually gets set on a timer interval, it will be called every second, and since the remaining game time property will represent the amount of seconds left until the game is over, let's decrement the remaining game time property by 1 if it is greater than 0. So type out if in parentheses remaining game time greater than 0, and then squiggly brackets remaining game time minus minus. The minus minus or dash dash or double hyphen is the decrement operator, so the opposite of the plus plus increment operator that we used earlier in the game with tutorial widget class. The decrement operator decreases the value of a variable by 1. Now, if the remaining game time has already reached 0, then the game should be over by then and we should be good to clear the timer handle for this function. So type else squiggly brackets get world timer manager parentheses dot clear timer, and then in parentheses pass in countdown until game over handle. Now moving on to the end game method, let's write down here void a game left tutorial game mode double colon and game parentheses squiggly brackets, and we're going to do a few simple things in this method. So first, we're going to call clear timer on all the timer handle member variables in this game mode class. Even though there will be points when specific timer handles get cleared, this method will kind of serve as a safe precaution to double check that no timer functions are running anymore, and then after that we will do some game lift related things. So let's clear the timer handles by writing get world timer manager parentheses dot clear timer, and then in parentheses let's pass in countdown until game over handle. And then I'm just gonna copy this line, I'm gonna paste it 4 more times because we have 4 more timer handles to clear. So in this second line, let's replace the parameter passed with end game handle. And then on the third line, let's replace this handle with pick a winning team handle. And then on this next line, let's replace this parameter with handle process termination handle. And lastly, let's replace this last parameter with handle game session update handle. Now let's perform some game lift functions and then terminate the server process. So first, when the game ends, we should terminate the game session that is activated on the server process so that we can reuse the server process running on this port to host another game session for a new match in the future, since the server process can only host 1 game session at a time. So to do that, let's type down here AWS double colon game lift double colon server double colon terminate game session parentheses. Now after calling terminate game session, you have 2 options here. You can either do some custom logic to clean up the server process, like reset game variables, kick the players out, etc. And once the server process is ready to host a new game session, you can call game lift server process ready, like how we did in the begin play function, to let game lift know that this server process can host another game session. Now for this tutorial, just to keep things simple, we will be letting game lift know that the server process is shutting down, so that when the server process restarts, the begin play function will run again and process ready will be called again. This just makes it a lot easier in the tutorial in terms of cleanup and reusing the server process for a new game session. Now keep in mind that depending on whichever implementation you choose to do, in some cases one approach can be faster for getting a server process ready again, and in other cases the other approach can be faster. But in our case, when shutting down a server process, we have to let GameLift know by calling the GameLift server process ending function, and this should be called generally after doing whatever shutdown cleanup logic that has to be done and terminating an active game session if there is one. So let's type AWS :GameLift :server :process ending parentheses. And lastly, let's actually stop the execution of the server process by calling the Unreal Engine request exit method. So type out f generic platform misc :request exit, and then in parentheses this method takes in a boolean parameter for whether or not you want to force the application shutdown. So we are just going to pass in false so that we don't have to force a shutdown and we can just exit cleanly. And to finish this method, let's wrap the last 3 lines of code in the hashtag if with GameLift hashtag and if compiler directives. So right here hashtag if with _GameLift, and then down here type hashtag end if. Now let's move on to the pick a winning team method. So down here type out void a GameLift tutorial game mode pick a winning team parentheses squiggly brackets, and this method will be responsible for choosing one of the 2 teams at random to win the game and make an HTTP request to the record match result API endpoint so that the player and game stats get updated in DynamoDB. But the first thing that we're going to do is clear the countdown until game over handle variable, because by this point the game should be over and there's no point in updating the game state's latest event property with the amount of time left in the game. So write get world timer manager parentheses dot clear timer, and then in parentheses pass in countdown until game over handle. After that, let's set the latest event and winning team properties of the game state, but first check if the game state is equal to null pointer by typing if in parentheses game state not equal null pointer, and then in squiggly brackets. Then cast the game state to a GameLift tutorial game state pointer by typing a GameLift tutorial game state pointer GameLift tutorial game state equal cast, and then in carets a GameLift tutorial game state, and then in parentheses pass in the game state. And let's do a null pointer check on that as well by writing if in parentheses GameLift tutorial game state not equal null pointer, and then in squiggly brackets. After those null pointer checks, let's set the latest event property to game ended by typing GameLift tutorial game state arrow latest event equal in quotes game ended. And like I mentioned before, let's pick one of the 2 teams, Cowboys or Aliens, at random to win the game. So let's generate a random number between 0 and 1 inclusive, and if it's equal to 0, then we'll set the winning team property in the game state to Cowboys, but if it's equal to 1, we will set the winning team property to Aliens. So type out if in parentheses fmath rand range, and then in parentheses 0, 1 equal 0, and then in squiggly brackets let's set GameLift tutorial game state arrow winning team equal to in quotes Cowboys, else, and then in squiggly brackets we'll set GameLift tutorial game state arrow winning team equal to in quotes Aliens. And remember, the setting of these game state properties is to make sure that the clients can be notified through their UI of the latest event and winning team changes. Now, before we move on to the making of the HTTP request, I just want to cover some edge cases for some of these if statements. So in the event that the game state is equal to null pointer, in the very, very rare case, let's call the endGame function in 5 seconds. So right here, else, and then in squiggly brackets, type out get world timer manager, and then parentheses dot set timer, and then in parentheses pass in the endGame handle, this, comma, ampersand a game lift tutorial, game mode, and game, comma, 1.0f, comma, false. Since we won't have this function running on a loop, we're just having it run once after a delay, and that delay will be 5 seconds, so the last parameter will be 5.0f. Also, in the very, very rare case in which the game state cast fails, let's also call the endgame function in 5 seconds. So over here, write out else, squiggly brackets, and then do the exact same thing as we just did. So copy this line where we set a timer for the endgame function to be called in 5 seconds. Copy that line and just paste it in that else block. Alright, now we can move on and make the HTTP request. So for the request, as you guys remember from earlier in the video, the record match result lambda function will be expecting a winning team and game session ID in the request body. So let's make a JSON object for the request body by typing t shared ptr and then in carets f JSON object. We'll call this variable request obj and we'll set it equal to make shareable in parentheses passing new f JSON object. And then let's set the winning team field to the winning team property in the game state by typing request obj arrow set string field and then in parentheses and in quotes the name of the field, which in this case would be winning team, and then comma the actual value, which will be game lift tutorial game state arrow winning team. And then let's get the game session ID by calling the game lift server get game session ID function by typing auto get game session ID outcome equal AWS game lift server get game session ID parentheses. And let's check if the call to the get game session ID function was successful by typing if in parentheses get game session ID outcome that is success parentheses and then squiggly brackets. Now if it wasn't successful, then let's just call the end game function in 5 seconds by typing down here else in squiggly brackets. Just copy this line where we set the timer for the end game function and then just paste it in this else block. But if the call to get game session ID was successful, then let's set the value of the game session ID property in the request body object to the game session ID by typing up here request obj arrow set string field and then in parentheses and in quotes the name of the field, which in this case is game session ID, and then comma the actual value for this property, which will be get game session ID outcome dot get result parentheses. Now let's serialize the JSON object into a JSON formatted string. For that we will need a f string variable and a t JSON writer variable. So type out f string request body and then t shared ref in carets t JSON writer carets. We'll call this variable writer and we'll set equal to t JSON writer factory carets create and then in parentheses pass an ampersand request body. Then let's actually perform the serialization and check if it's successful by writing if in parentheses f JSON serializer serialize and then in parentheses pass in request obj.to shared ref parentheses comma writer squiggly brackets. Now if the serialization was not successful for whatever weird reason, then we will just call the endgame function in 5 seconds by typing else squiggly brackets and then copy a line of code where we already do that and then paste it in this else block. Now going back up, if the serialization was successful, then let's actually make the HTTP request. So first we need a HTTP request variable, so type out t shared ref and then in carets I HTTP request, call this variable record match result request and we'll set it equal to HTTP module arrow create request parentheses. Then let's bind a onProcessRequest complete delegate function to this request by typing record match result request arrow onProcessRequest complete parentheses dot bind uObject, and then in parentheses pass in this comma ampersand a GameLift tutorial game mode double colon on record match result response received. Next, let's set the URL of this request by typing record match result request arrow set URL, and then in parentheses pass in API URL plus in quotes slash record match result. And then this will be a post request, so type record match result request arrow set verb, and then in parentheses and in quotes post. And we have to set two headers for this request. So first let's do the authorization header by running record match result request and then arrow set header, and then in parentheses and in quotes authorization. And then the value for this authorization header will be the server password, and hopefully that will contain the right value for the Lambda authorizer. And let's do the content type header by running record match result request arrow set header, and then in parentheses and in quotes content dash type comma, and the value for this header will be in quotes application slash JSON. Then let's set the request content by typing record match result request arrow set content as string, and then in parentheses pass in the request body variable. And finally, let's send the request by typing record match result request arrow process request parentheses. And I made a typo here. This should be a capital M in record match result request. And to finish this method, let's wrap everything besides the call to clear timer at the beginning of the function in the hashtag if with GameLift hashtag and if compiler directive. So up here, type out hashtag if with underscore GameLift, and then down here, type hashtag and if. Alright, moving on, let's implement the handle process termination method by writing down here void a GameLift tutorial game mode double colon handle process termination parentheses squiggly brackets. And as we wrote earlier, this function will be called every second starting from 5 seconds after begin play was called. So the purpose of this function is to periodically check for server process interruptions by GameLift. So let's check the status of the process terminate state member variable by writing if in parentheses process terminate state dot status, and then in squiggly brackets, if the status is set to true, then that means at one point the onProcessTerminate handler function was at one point invoked by the GameLift service. So the first thing we will do in this case is clear some timer handles, because for this tutorial, if we get a server interruption, no matter how much time we have until the process is scheduled to end, we're going to end the game right away. So let's type get world timer manager parentheses dot set get world timer manager parentheses dot clear timer, and then in parentheses let's start first with the countdown until game over handle. And I want to clear a couple more timer handle variables, so let's copy this line and just paste it 2 more times. And then the next timer handle that we're going to clear is the handle process termination handle variable, because we shouldn't be calling handle process termination if we figure that the server process was interrupted. And lastly, let's also clear the handle game session update handle, because if the server is interrupted and we're about to end the game, then we don't really care about backfill requests or people joining the game anymore. Now let's set the latest event property in our game state to let the clients know of this interruption. So first let's initialize an f-string variable and call it process interruption message. Now the get termination time method is called in the event that the onProcessTerminate handler function is invoked. Now this method can return a couple of values in the case where the function call was successful. It will either return a long value of -1, meaning that the server process can shut down at any time because the time when it is going to shut down is unknown, or it will return a long value representing the time in Unix epoch timestamp format in seconds when the server process is scheduled to shut down. In the case that the call to get termination time fails, then the termination time property in our process terminate state variable will still contain its default long value of 0. Now, very quickly, I actually made a minor harmless typo earlier in this video with regards to setting the default value of the termination time property in the constructor of the fProcessTerminate state struct. So let's go back to the GameLive tutorial game mode header file, specifically again up to the fProcessTerminate state struct. And notice in the constructor that I set the default value for the termination time value to 0.0L. Get rid of the 0.0L and just have it as 0L. And I just realized that before, when it was 0.0L, that was a value of type long double. Technically this is okay because when you assign a long variable, or when you assign a value of type long double to a long variable, all the numbers after the decimal point get truncated anyway. That's really the only difference between a long double and a long, is that a long double is a decimal, whereas just a plain long has no numbers after the decimal point. And for me, it's just a personal preference, but don't worry if you missed this for some reason, because I didn't point this out earlier, because setting this to 0.0L or 0L will technically make no difference in this tutorial. And just a fun fact, the only reason why the termination time property is of type long is that the get termination time method from the GameLive server SDK returns the scheduled termination time of the server process if there is one in a variable of type long. Now the interesting thing is that in Unix epoch time format in seconds, the max value that a long variable in C++ can contain is equivalent to some date in 2038. So hopefully by then the get termination time method will be modified to return a value of type long so that it can return values greater than the max value of a long by the time 2038 comes by. Luckily, Unreal Engine is already way ahead here, because as you guys will see very shortly, when we calculate how much time we have until the server process terminates, we will use a built-in Unreal Engine function that returns the current Unix epoch time format, we will be using a built-in Unreal Engine function that returns the current time in Unix epoch time format in seconds, but that function returns a value of type int64, which is similar to long in that it's much bigger than a long, and I could be wrong. Definitely correct me if I'm wrong in the comments below, but I believe the max and min values for a variable of type int64 are the same as the max and min values for a variable of type long. So with that said, let's go back to the GameLive tutorial game mode C++ class, and depending on the value of the termination time, let's set the process interruption message accordingly. So write if in parentheses process terminate state dot termination time less than or equal to 0L, and then squiggly brackets. And in this case, let's set process interruption message equal to, in quotes, server process could shut down at any time. Now, if the termination time is a value greater than 0, then that means that the getTerminationTime method returned a time value in Unix epoch format in seconds. So let's calculate the difference between the termination time and today, right this very moment when this method is called and reaches this point in the code, and store that in a variable of type long. So type out else, and then in squiggly brackets, long time left equal process terminate state dot termination time, and then we're going to subtract the current time in Unix epoch seconds. So the method that returns that, the current time in Unix epoch seconds, is fDateTime now parentheses .to Unix timestamp parentheses. And you theoretically could make this time left variable of type int64, since the datetime now to Unix timestamp method returns a variable of type int64, but I decided to make it of type long just to keep consistent with GameLift's getTerminationTime method. Now let's set process interruption message equal to fstring :printf, and then in parentheses pass in text, and then in parentheses pass in quotes server process scheduled to terminate in %LD space seconds, and then comma time left. Now, for those who may be a little confused at this line of code we just wrote, the printf method is needed here because there is no standard straightforward way to convert a long variable into an f string, and the %LD is what's called a custom format placeholder for a value of type signed long, hence why it's %LD instead of %LU, because %LU is a placeholder for unsigned longs, so only positive longs. But by default, variables of type long are signed. Now, am I expecting the time left variable to ever be negative? Usually no, but there may be very rare instances when the server process is scheduled to shut down before this method gets called. So in that very rare case, we would need to format the string to expect both positive and negative long values. Then once the process interruption message is set, let's set the latest event property in the game state. So let's do a null pointer check on the game state by typing if in parentheses game state not equal null pointer, and then in squiggly brackets let's cast the game state to a GameLift tutorial game state pointer by typing a GameLift tutorial game state pointer GameLift tutorial game state equal cast, and then in cast, and then in carets a GameLift tutorial game state, and then in parentheses pass in the game state. Then do a null pointer check on that by typing if in parentheses GameLift tutorial game state not equal null pointer, and then in squiggly brackets now we can set GameLift tutorial game state arrow latest event equal to process interruption message. And lastly, let's call the endGame method 10 seconds from now by typing get world timer manager, and then in parentheses dot set timer, and then in parentheses pass an endgame handle, comma this, comma ampersand a GameLift tutorial game mode end game, comma 1.0f, comma false, because we don't want this function to be run on a loop periodically, comma 10.0f, because we want this function to be called 10 seconds from now. Now let's move on to the last timer delegate function, handle game session update. So right down here, void a GameLift tutorial game mode, handle game session update, and then in parentheses squiggly brackets. And this function, as we wrote earlier, will be run once a second approximately. And the purpose of this function is to constantly check if the game session has been activated yet. And then later on in this video, it will be further improved upon to check if the game session's backfill request has been fulfilled yet. But to check if the game session has been activated yet, we're first going to check our game session activated flag. Because once we know that the server process is hosting a game session for the very first time, we're going to set the game session activated flag to acknowledge that we know that there is an active game session. In response to that, we will quote unquote start the game, which in this tutorial just means running the countdown function every second and calling the pick a winning team function in approximately 4 minutes. So let's check if we already know that a game session started, if one ever did start, because we're not going to start the game multiple times, we're only going to start it once. So type if in parentheses not game session activated, and then in squiggly brackets, if we don't know if a game session started, then let's check if one started by seeing if the onStart game session's handler function was ever invoked. And luckily we can do that through these start game session state memory variables. So right, if in parentheses start game session state dot status, and then squiggly brackets. And like I just said, let's set game session activated equal to true so that we don't run this block of code inside this if statement more than once, since we will be calling set timer on a couple of functions. And one of those functions, like we just mentioned, was pick a winning team. So type get world timer manager parentheses dot set timer, and then in parentheses pass in pick a winning team handle, and then comma this comma ampersand a game lift tutorial game mode double colon pick a winning team comma 1.0f, and this parameter doesn't really matter because the next parameter is going to be false, since we only want this function to be run once after a delay, not necessarily repeatedly on a loop. And then the last parameter will be when we want this function to be called. So like I mentioned before, we initialized the remaining game time variable in the constructor to be 240 because that is about 4 minutes in seconds, and that's when we want this function to be called. We want it to be called in 4 minutes because that's how long we want our game to last approximately. So type out in parentheses the word float because we need to cast the variable to type float, since remaining game time, as I type it out, is of type int. So, but this function takes in a float for the last parameter. And lastly, let's call set timer on the countdown until game over function as well. So type get world timer manager parentheses dot set timer, and then in parentheses pass countdown until game over handle, comma this comma ampersand a game lift tutorial game mode double colon count down until game over, comma 1.0f, and this time this parameter does matter because the next parameter will be true because we do want this function to be called repeatedly, approximately once a second, comma, and then for the initial delay before the function is called for the first time, we're just going to make this 0.0f because we want this function to actually be executed immediately. And lastly, let's implement the last function we defined, which was the response handler function for the HTTP request to the record match result API endpoint. So type void a game lift tutorial game mode double colon on record match result response receive, and then in parentheses pass in f HTTP request ptr request comma f HTTP response ptr response comma bool b was successful. And then in squiggly brackets, we're not actually going to do anything with the response. Basically the point of this method is to just know when the request to the API finished, whether the call succeeded or not, whether the Lambda function actually wrote to DynamoDB or not, even though it usually will. And once we know that, let's call endgame in 5 seconds by typing get world timer manager parentheses that set timer, and then in parentheses pass in the endgame handle, and then comma this comma ampersand a game lift tutorial game mode double colon end game comma 1.0f comma false comma 5.0f. And one more correction that I want to make, it's just a minor harmless preference thing, but scroll back up to the handle process termination method, specifically where I calculated the value for the time left local variable. I personally prefer to do explicit cast because, like I said before, the toUnix timestamp method returns a value of type int64. So after doing the subtraction operation and storing the difference in a variable of type long, an implicit cast is performed to convert the value to a long in the end, but I just prefer doing explicit casts so that it's clear to the reader of the code that at least one of these two values is not of type long. So to do an explicit cast, let's unwrap this whole thing to the right of the equal signs in parentheses. So process terminate state.termination time minus update time now toUnix timestamp. Just put that all in parentheses, and then before that, after the equal sign, add another pair of opening and closing parentheses and type out the name of the type that you want to cast this to. So in our case, it's long. And I know this is kind of weird because, again, it is mainly just preference. There's nothing wrong with an implicit cast, it's just an explicit cast can help with readability or debugging here and there. So even if you didn't have this explicit cast, the implicit cast will work just fine, as it usually does in most cases. Okay, with all of that said, we are now ready to build the project once again. Now make sure to just do a quick scan of the code, double check for small typos here and there just in case, because the code we just wrote in the game mode class is not really testable in the Unreal Engine editor. So we're going to just go straight to compiling the server to make sure that there are no compiler errors. So for the solution configuration up here in this drop down menu, on the top left, make sure you have development server selected. Keep Win64 selected for your solution platform. And then once you have those options selected, go to your project on the right side and then right click it and select build. And once the server is finished compiling, assuming with no errors, let's go back to the Unreal Engine editor and tinker with the packaging settings really quickly before we package the server. So go up here to the top left corner, go to file, and then go to package project, and then where it says build target, make sure that you have GameLoop tutorial server selected. I believe it should be selected since we just built the project in the development server configuration in Visual Studio. Once you have that selected, click on packaging settings. And in here we're going to do a couple of things. First, scroll down to where it says additional non-asset directories to package for dedicated server. It might be a little cut off at the end, so let's maximize this window so that you can better see it. And essentially, similar to the client, we need to package the URLs folder containing the text files because the server will be relying specifically on the API URL text file, since the record match result method is on the same API that hosts other methods that the client mainly uses. Again, I recommend in a production application to separate the server and client Lambda functions into two separate APIs, with the one for the server to be in a private VPC network, but that is outside the scope of this tutorial, so let's just click on the plus button here to add a new non-asset directory to package for the dedicated server, and then click on the three dots, and let's in this file explorer like window, let's find and select the URLs folder. According to the path, it seems that I'm actually already in the folder, so I can just go ahead and click on select folder. Probably remembered from when we did the additional non-asset directories to package, probably just remembered that same folder that we were in before. And lastly, I also want to check in the project section that the checkbox for the include debug files option is ticked off, because in order to make the server build upload go faster, we can reduce the file size of the dedicated server build. And debug files generally are in the form of PDB files, and those can take up a lot of space. So turning this flag off can be good for that purpose. Now, as long as you have the PDB debug files locally, you can always remotely connect to the EC2 instance that's hosting your server processes and dump the log files from there onto your local machine so that you can better read the logs. The same thing applies to, client builds that you distribute to other people. That's why we also turn this option off for client builds as well. So to make them smaller, and if you want to read if you want to read logs from outside client builds, those people can send you their logs and then you can read them on your local machine. Because the PDB files are mainly used for better understanding log files, tracing them, and debugging them, because without the PDB files, the logs don't show as much information. It's kind of hard to explain, and maybe even a little bit outside of my scope and may require further research to better understand. And whenever you build the project in Visual Studio for whatever configuration and platform, the PDB file for that configuration and platform usually gets built as well, along with the main executable and other files, and those can all be found in the local projects directories binary folder. They can be found in the local projects directory, specifically the binaries folder. So keep this option toggled off, and we can now close out of here. With all of that said about reducing the file size of the server build, before we finally package the server, let's go to File Explorer, specifically where the local project directory is located, and go inside the Windows Server folder, which is where we are putting the package server build files in. And let's just delete everything besides the stuff that we need for GameLift. So don't delete the VC redistributable file, and don't delete the install.bat file, but let's delete everything else. So these text files, go ahead and delete those. The server executable, the GameLift tutorial folder, and the engine folder, just go ahead and delete those as well. And the reason I want to do this, and I'm not sure the reason behind this or if it's even 100% correct, but we've done many things since the last time we packaged the server, including disabling plugins and not including debug files, which will save us space. But if we just package the server as normal without deleting the old build files, then those removal of files that I just mentioned, like the disabling of plugins and not including debug files, don't get applied. Files get overwritten when repackaging, but not deleted, as far as I know. So I want to delete those files and folders just to be extra safe and get a brand new fresh build. But of course, keep the old files that we added in addition to the package build, like the install Windows batch script and the VC redistributable file, because you need those once again when you upload the server build to GameLift. You need these two files to be executed so that the environment in the EC2 instance has all the prerequisites for running an Unreal Engine server executable. And by the way, again, all of this, just want to reiterate, is due to the fact that we are trying to reduce file size to make the server build upload faster. When we package the server again with the backfill code changes, we won't do this. We won't go in the File Explorer and delete files, because at that point the main thing that is getting rebuilt is the server executable. With all of that said, we can go back to the editor and finally package the project. So go to File on the top left, go to Package Project. Again, reiterating here, for the build target, make sure you have GameLift Tutorial Server selected, and for the build configuration, make sure you have development selected. Now, you don't necessarily have to have development selected. You can also have any of these other configurations selected. You can even have shipping selected, but just keep in mind with shipping, I could be wrong about this in case it changed, but if you choose the shipping configuration, then log files won't be generated. As for the debug configurations, they just have some special stuff associated with them in terms of with debugging with Visual Studio, I believe, and the Test configuration, I'm not too familiar with that, but again, development configuration and server target for this tutorial. Once you have those selected, go to Windows and then select Windows 64-bit to package the server in the Windows or for the Windows 64-bit solution platform. Make sure for the folder you want to package the project to, make sure you have your project directory selected, and then click on select folder. And if you want to see the logs of the packaging, then just click on the show output log button here on the bottom right corner of the screen. Once the server is finished packaging, let's open up command prompt so that we can upload the server build to GameLift. Now, I know in an earlier part of the tutorial I tested the server build against GameLift local to make sure that the server on a very bare bones simple level was functioning and not crashing. However, the reason why I'm not going to do that in this part of the tutorial is 1, to save time and make the tutorial go a bit faster, and 2, a lot of the GameLift features that we were testing involve matchmaking, which as far as I know, but correct me if I'm wrong, GameLift local does not have heavy support for testing that right now. So let's go ahead and upload the build to GameLift. Hopefully your AWS CLI is still configured to the same user credentials that you used last time. If so, just run AWS configure if you want. But my AWS command line interface is already configured, so I'm not going to run AWS configure again. But if you at one point change your AWS CLI configuration, and go ahead and run this. But I'm going to just jump straight to uploading the build by typing AWS GameLift upload-build, and then this function will take in a few parameters. The first one will be --name, and we're going to keep the name of this build the same as the build from last time. So GameLift tutorial, and then the next parameter will be --build-version. Now, the value for this parameter will not be the same as last time. Last time it was 1.00. Now I'm going to make it 1.0.1. The next parameter is --build-root, and this is basically the absolute file location path of your server build directory, which should be the same as last time unless you move the project directory since then. But for me, it's going to be in quotes because my path has a space in it. So in quotes c://Chris/documents/Unreal space projects /GameLift tutorial/Windows server, and then a closing quote. Now again, this path will be dependent on where you put the packaged server build directory, so this will most likely be different for you. The next parameter is --operating-system, and this will have a value of Windows _2012 in all caps because we are uploading a Windows server build. And then the last parameter that we're going to use is --region, and the value for this will just be the code of the region that you are operating in. So for me, it'll be US-East-1. Once you have all that typed out, go ahead and press enter. By the way, this command will be in the description below. Once the server build has finished uploading, let's go to the AWS Management Console. Make sure you're logged in, and under where it says Find Services in the search bar, type in GameLift and select on the option labeled Amazon GameLift. And then from here, find the server build with the name and version that you specified in the AWS GameLift upload build command. So in my case, my build was named GameLift Tutorial, and it was version 1.0.1. So click on that once you find it, and click on the name specifically, so that'll take you to this build page. And from here, in order to create a new fleet for this build, click on where it says Actions, and then from the drop down menu, select the option labeled Create Fleet from Build. Now in this create fleet page, we're going to follow a lot of what we did in a previous part of the tutorial with some minor differences and additions. So first, for the name of the fleet, we are going to follow a little different naming convention than what we used last time, since this is our second fleet Now, and it's good to have a way to differentiate between fleets similarly to how we have different versions for these server builds. Although for the builds, unlike what I just did, you should probably have different names for each build of the same game even. But for this fleet, let's go ahead and name it the name of the build first, so game of tutorial, the name of the build that it's built off after, and then space the instance type that this fleet is using. So I'm getting a little technical here, but if we scroll down, we're using currently the free tier eligible instance type, which at the time of recording this video is c5.large. So let's just type out c5.large and then space. I want to type out the operating system of this fleet. So in our case, it's going to be Windows. So type out Windows, and then what kind of fleet is this? Is this on-demand or spot? Like we did in a former part of the tutorial, this will be a spot fleet to make the fleet a little cheaper to operate in terms of price and cost. And then I'm just going to call this, and then I'm going to do space fleet to signify that this is a fleet. And then after that, the version number of the build that we're building a fleet off of. So I'm going to call this, or I'm going to type 1.0.1 because in my case that is the version of the build that we are building a fleet off of. And as I just mentioned, this will be a spot fleet, not an on-demand fleet, because spot fleets are generally significantly cheaper than on-demand fleets. So by where it says fleet type, select the drop-down menu that currently says on-demand and select spot. Now let's keep the rest of the default fleet settings for the fleet details section as well as the instance type section. So scroll down to the process management section, and under where it says server process in bold, let's configure a server process to run on each instance in this fleet. So for the launch path, once again, this value should be the path of the server executable in the binaries folder in our package build. The game folder labeled here is synonymous to the Windows Server folder in our local project directory. So type in here the path of the server executable in the binaries folder relative to the Windows Server folder. So in my case, it will be gamelift tutorial / not / binaries / win64 / gamelift tutorial server.exe. Now, if you're not sure, you can always go to your local project directory in File Explorer, specifically the Windows Server folder, then go to the folder named after your project. In this case, it's gamelift tutorial, and then the binaries folder, and then the win64 folder. And in here, you can go up in the file path bar here and copy the path up to, but not including the path of the Windows Server directory. And then you can paste it in here, plus a slash, and then the name of the server executable with the file extension. And for the launch parameters, remember last time we specified a port parameter for the server process to run on. Now, we will be defining a password parameter in addition to that so that the server process can make a successful request to the Lambda authorized record match result API endpoint. So type out -port equals, and we'll set this equal to 7777, and then space -password equal, and then the value you used in the Lambda authorizer function for the record match result API endpoint. In our case, we made the value to check the authorization header for dummy. So I'm going to write dummy, but make sure you write the value that you used to check incoming request authorization headers for. And then once you have that all typed out, click on the green check mark button to save your changes. Now for this fleet, I'm only going to specify one server process because I want to test the ability to run multiple game sessions on the server processes running on a specific port, so that we are correctly terminating the game session and shutting the server process down so that the process can be started back up and host a new game session on that port. this is also why we left the value for concurrent processes for this server process at its default value of 1, because we don't want multiple server processes running on the same port. But now we have to open up that port 7777 to incoming player connection. So to do that, scroll down to the EC2 port settings section and click on add port settings to add a new entry in this port settings table. And for the port range, since we only specified one server process to run on port 7777, let's just type here 7777. For the protocol, change this from TCP to UDP, and for the IP address range, type in 0.0.0/0 and click the checkmark button, the green checkmark button, to save your changes. And lastly, make sure that the protection policy is set to the default value of no protection, because later when we test the server, we are going to scale the fleet down manually to simulate a server interruption event in the middle of a game. And full protection only protects server processes from interruptions caused by fleet capacity scale down events, not failed health checks and spot interruptions. So with that said, let's go ahead and create the fleet by clicking on the initialize fleet button. And if you remembered from last time, a fleet takes a while to get set up and fully activate, so you can track the status of your fleet in the events tab. So click on where it says events, while occasionally clicking on this refresh button to see the latest events. In the meantime, feel free to pause the video and come back in around 20 minutes, because that's usually how long it takes for the fleet to fully activate. Once you guys see this fleet scaling event after refreshing the events, let's go ahead and refresh the page to see the other parts of the UI be up to date, like the status, number of active instances, and number of active servers. And before we test the server by running a couple of clients, let's change the fleet destination inside the queue associated with the matchmaker. So go to where it says fleets up here by where it says Amazon GameLift, and click on the option labeled queues, and then go ahead and click on your queue, and then from here click on the actions button and select the edit queue option. And from here, under where it says destinations, click on the pencil button to the right of the only entry in this destinations table, and all we are going to do is replace the fleet for this entry with the new fleet we just made. So under where it says fleet or alias name, just click on the value, and you should see this drop down menu appear with all the fleets in the region specified in this entry. And let's just select the new fleet that we just made. Now you should see in parentheses to the right of the fleet ID the name of the fleet. So by looking at the name of the fleet, you should know which fleet was the one you just made. So select that, click on the green check mark button to save your changes, and then click on the submit button. And then once that's done, we now have to repackage our client. So go to Unreal Engine, specifically File on the top left corner, go to Package Project, and this time for the build target, select GameLift Tutorial instead of GameLift Tutorial Server, because we're building the client this time. And then go back to File, go back to Package Project, and then go to Windows and select Windows 64-bit, and then make sure in this File Explorer like window that you have the project directory selected, and then just go ahead and click on select folder to begin packaging the client again. Once the client is finished packaging, let's go ahead and open up a couple of clients so that we can test our server. So go to File Explorer, specifically where our project is located, and go to the Windows No Editor folder, and from here just double click the GameLift Tutorial application file twice so that you can open up two clients at once. And remember from the last part of the tutorial that we open up the executable in a way so that it would take up about half of the screen approximately. So let's just move those two windows side by side, and then in each client just log into a different account. So I'm going to log into a floperam account on this end, and then the other client I'm going to use Google Sign-In. Again, you can use Google Sign-In for both accounts. You can use Cognito Sign-In for both accounts, just as long as you're signing into two different accounts. So just going to log into the account, and then once you're logged into both clients, in different accounts, just go ahead and click join game in both of those clients so that we can start looking for a match on both clients. And then, after a certain period of time, we should both get into a match. And as you can see, it seems like it's working. We have the countdown timer going. If I move on one client window, you see the exact same movement replicated in the other client window. And if I do alt tab to move between other client windows, I can also start controlling this guy, and you see the movement is also replicated on the other guy's end as well. And as you can see, also the other parts of the UI, the ping, the team name. Remember, we made aliens blue and we made cowboys red, and right now the teammate count on each guy's team is 1, which makes sense because we only have 2 people currently. You can theoretically have 4 players in one game at this point. You kind of just have to click join game on all 4 of the clients really fast. Otherwise, there's a pretty high chance they won't get in the game, just because GameLift's flex match service works really fast to create potential matches. And since we have one server process running right now, we have to wait until, we have one server process running on one instance right now. We have to wait until the game is over to get another match going, but that's fine because right now I kind of want to just test to make sure that the game can complete its full lifespan. So by the time this game ends in about 140 seconds, we should see which team won at random. It's about 50-50 odds, and then after that we are going to check DynamoDB for the updated player stats and game stats. But in the meantime, we can actually go to the Amazon GameLift dashboard. Let's go back to the fleet, so click on queues and select fleets from the drop down menu. Let's select the fleet that we just made, and as you can see in the game sessions tab, we currently have an active game session. Ignore the game session underneath that. I was testing this earlier as well, but click on the ID value to get details about the players in the game. And right now, as you can see, we have 2 active player sessions, which makes sense because we have 2 active players in the game. So if I bring both those windows back up, we have 2 active player sessions in the game. So that makes sense. Now remember, we also enabled the escape key, but we're going to test that when we join another game session. So let's just let this game session on the server process run its course. So we got about a minute left until this game session is over, but we will later test on other features of the game, such as in the case of a server interruption, since I made a big deal about that. We'll also test the escape key to make sure that clients can go back to the main menu. And when clients leave, like I mentioned before, we mark their player session as completed for backfill purposes. And right now, actually, believe it or not, and you'll see this later, when a player leaves the game and their player session is marked as completed, since we don't update the matchmaker data, technically a player that left the game, their player stats will still get updated, which I guess kind of makes sense, but just keep that in mind that you don't necessarily have to be in the game for your player stats to be updated, because your player stats only have to be updated if the player is in the matchmaker data. So as you can see, the game's over. You and the Cowboys lost. You and the Aliens won. So we should see. So as you can see, the client on the left side, their number of losses increased by 1, and on the right side, the number of wins increased by 1. And now, before I move on to checking the GameLift and DynamoDB dashboards, some people have asked me when you should repackage the client, because obviously if you make changes to the server that don't affect the client, you shouldn't have to repackage the client. But with all the changes we just made in the project, we kind of had to repackage the client in that case. So I'm not entirely sure when you need to and when you don't need to repackage the client. Now with that said, let's go back to the game lift dashboard, and if we refresh now, you'll notice that the player sessions are in completed status. This makes sense because we terminated the game session, so if you refresh this page, you'll notice that the status of this game session is terminated. Even if we go back, you'll also see that the game session is in terminated state. Also, while we're here, also go to the events tab, click refresh. Make sure you don't see any messages with an error code, because sometimes that can happen if you shut down your server process, not cleanly, or you didn't call process ending, for example, and you just shut down your process randomly, stuff like that. And everything seems to look good here. So now in a separate tab in your browser, go to the DynamoDB dashboard, specifically the tables page, and let's make sure that our tables are updated. So first, let's look at the easy one. Click on the players table, go to items, and right now, at least in my case, I only have 2 users. It's just easier to find the 2 user in that case, because these were the 2 users in the game, and as you can see, one of them has 1 loss and 3 wins, and the other one has 3 losses and 1 win. Now let's check the match results table, because that should have been the other table that was updated as a result of a game ending. So as you can see, we have 3 entries right now, so we kind of have to figure out which one was the one that was recently made. So trying to look here, it could really be any of them. I'm just going to click on this first one, see if I get lucky. Let me expand the players. So okay, it probably wasn't this one, and the reason I can tell is because the skill attributes of each of these players are 50 and 50, meaning at one point they had a 50% win-loss ratio, which was not true in that case. I remember one player had 1 loss and 2 wins, and the other one had 2 losses and 1 win. So one player's attribute should be like 66%, and the other player's skill attribute should be like 33. So let's just expand these. So let's see, are these guys, oh, sorry about that, guys, my mouse is lagging right now, and we gotta expand all of these. So this is also 50-50, so I don't think it's this one either. Let me do the last one. So this is probably gonna be it. Yeah, so all right, this makes sense. So we had 1 player on the Cowboys, and that makes sense. So the winning team in this case was the Aliens, I do remember that, and that player was the player on the right with the higher skill attribute, which makes sense because if you remember before we joined the game, the player on the Aliens was on the right side, and they had, I believe, more wins than losses, hence the higher skill attribute value. And the player on the Cowboys was on the left side of the screen, if I'm not mistaken, and that player had less wins than losses, so obviously that player's skill attribute value will be lower. Alright, now let's go back to the clients and make sure that we can run another game session on a server process on the same port. So go ahead and click join game on both of these clients, and as you will notice, we are going to be looking for a match, and it's actually going to take, it's not instant anymore, because as you can see now we have actual skill attributes. See, there was a little delay. Normally it would be instant, but because now the skill attributes are farther and farther away from each other, the rule set has to now apply its expansions on the fair team skill rule to get these players in a potential match. So if I go in here, so we got 1 guy in the Alien, 1 guy in the Cowboys, actually same teams as before, ironically. And what was I going to say? Okay, so one thing I want to test is, let's go back to the game lift dashboard. So let's go back here and let's go to the game sessions tab. Let's click on refresh, and as you can see, we now have a new game session, a new active game session on the exact same IP address and port as the last game session. And if we click on this game session again, we should see 2 active player sessions. Now if I go back to the clients, so let's say so let me test the escape key now. Let me actually leave the game. So if I press escape, that should take me back to the main menu. And that seems pretty normal. And if I click on the refresh button, we should see one of those player sessions go to the completed state, because in our logout function, we do terminate the player session. So that seems to be working normally. Now, another thing I want to test is the pre-login function logic. Can we get into a game unauthorized? So, when these clients are joining the game, normally they pass in a valid player session ID and player ID like we talked about earlier. But what if we just joined it just using the open level function, right? Because right now in our fleet settings, anyone can join the game, right? That's literally technically what we did. So let's copy this IP address and go back to that client that left the game, and then press the it's the tick mark, it's the key on your keyboard with the tick mark and the tilde. So just click on that inside this client and type out open, and then I guess space, and then copy that value, colon the port you use for the server process. So in our case it was 7777, and press enter and see if you can join the game. See, you didn't join the server map. You don't see yourself in the third person example map right now. You actually went straight back to the main menu map. That's because the pre-login function is doing its job. And if you do that again, if you press the key with the tilde and the tick mark on it, then you'll get this, terminal command prompt like thing again. And if you do open, same thing, copy the IP address, and then do colon the port 7777, and this time add some options. Try to trick the server. Do like question mark player session ID equals dummy, and then question mark again player ID equal dummy, and then press enter again. You still can't join the server because, like we did in the pre-login function, it checks that the player ID and player session ID are legit, meaning they match up with each other, and the player session ID is that of a player session object that is currently active, currently reserved, not active, not completed, not timed out. And let's just quickly go back to the other client. Now I know that was really fast there. I kind of went back right when the game ended, but it said you and the Cowboys lost, so this guy, same team lost. I guess this client's just really unlucky. So the Cowboys lost, and if we go back to this client, the results won't update on this client because we're not reloading the main menu widget. But if we go back to DynamoDB, first off, let's refresh this table. And I believe this new entry is right here. I believe, I could be wrong. This is in the match results table, right? No, it's not this one. It probably is this last one. It's probably sorted in, I guess, ascending order in terms of date. I'm not really sure, to be honest. I don't think that's checkable. Yeah, see, because the skill attribute values are lower than last time, so this makes sense. Yep, Cowboys losing team again. Aliens is the winning team. That makes sense because the Aliens had the player with more wins and the Cowboys had the player with more losses. Now if we go to the players table, check on that as well, you'll see one player has 1 loss and 4 wins, and the other player has 4 losses and 1 win. You just don't see it updated in that one client window on the right, because in that case we would have to reload the main menu widget to do that. Now the last thing that I want to test is what happens in the event of a server process interruption. So let's go back to the clients. Let's just open them both back up again. Press join game in both of them to get into a new game, and it's going to take some time. Actually, it's going to take even more time now because their skill attributes are even more away from each other. And third time in a row, I don't know why it is. I guess we could call it luck or something, but same teams as before. I mean, that's okay. That can happen sometimes. Let's go back to game lift now, and let's go back to the fleet page, and as you notice, there's now a new active game session. But that's not what I'm testing. We've tested that works before. Go to the scaling tab and then scroll down, and then where it says auto scaling policies underneath that, it says manually adjust the desired instance count to. So right now it's set at 1, so that makes sense because right now the desired instance count is 1 instance. So we have 1 instance running with 1 server process. So let's change that number from 1 to 0. And then click on the check mark button to save your changes and simulate a server process interruption via a fleet scale down event, because that's what we're doing. We're scaling down the number of instances in a fleet manually, and because we don't have full protection on, this server process should be scheduled to terminate. If you did have full protection on, then even in the case of a fleet scale down event, the server process would keep running until the game session was terminated. And as you can see, I know it's cut off here, but it did say server process scheduled to terminate in 269 seconds. So that means when we call get termination time, it was approximately, I guess, a little more than maybe about